What is up, my farming gang, and my learners out there, my people who want to stay smart during the summer? What is up? Today I'm going to be showing you how does a refrigerator work. How fridge works. And this is something I actually had a question for a very long time, but it's actually quite simple, and I'm going to show you guys how it does work. First, there's like this one concept that you guys need to understand, and that's how heat is in everything. So cold and heat, right? Like summer and winter time, you feel cold during the winter time, you feel hot during the summertime. But actually, cold is not really a thing. It is just the loss of heat. Heat is the only thing that exists. There's no such thing as cold. There's no cold particle. There's only heat, which is more energy in something. So cold is the absence of heat, which is absence of energy. So why is this important? Well, it helps us visualize what the heck is happening. And because we only know that there's heat that actually exists, there's no such thing as cold, it helps us understand why the refrigerator works. So we have a refrigerant. You probably heard this before. Refrigerant, something like that. You probably heard this before. Maybe your dad said it. Kind of confusing word if you don't know what it is, but all that the refrigerant is that it's a low boiling point liquid. Low boiling point liquid. And the reason why that's important is because it changes states very quickly. So it could go from liquid to gas very easily. And yeah, it's good. It's good for what the refrigerator does, as I explain more. So another thing that you guys need to understand is that a liquid has less energy than gas, right? Gas is bouncing all over the place. Well, liquid's more like mellow. We chill like that. And so gas has more energy, and liquids have less energy than the gas. Ooh. Less energy than the gas. So this refrigerant, this low boiling point liquid, actually runs through the back of your fridge in this coil, right? Not coil, excuse me, in these pipes. And we have a compressor down here, and it compresses the liquid to push through upwards to follow this pipe system. And what's cool about this is because it's a liquid, right? It's not a gas yet. It could actually absorb energy. And gases could absorb energy too, but liquids could absorb it better because there's less of it. Mother Nature wants to disperse energy, disperse particles. It's the concept of entropy. But she wants to disperse heat. So when you put your hot food in the refrigerator, like an apple, that's room temperature, but it's still pretty hot to this low boiling point liquid. When you place that apple in the refrigerator, the heat wants to spread out. And so it goes into the liquid, the heat does. And so that as the apple gets quote unquote colder, it has less heat, then the liquid heats up more. And it carries this heat actually to the outside of the refrigerator. So what it's doing is that it's taking the heat and then putting it outside, taking the heat, putting it outside. And so that's why the refrigerator feels cold. And that's also why during the summertime, you can't leave the refrigerator open and pretend that it's air conditioning. It won't do anything because it's just recycling the same heat that's in your house. Anyway, once the heat goes back outside, it gets dispersed, and it does that very cool. It's actually very cool how it works. We have a coil, right? And so our refrigerant, it actually turns into a gas because it is low boiling point liquid. It turns into this gas, so it has a lot of energy. It has to release it all. So this gas travels through this coil that's on the outside of the refrigerator, and as it travels through there, it actually releases the heat back into the environment. And so that's why also the refrigerator is cold. We have the heat on the outside, cold on the inside. But what is also cool is that this, on a good refrigerator, is made of copper. And copper is kind of special because, number one, it's cheaper than most other metals. And number two, it's because of its C value, which is the specific heat capacity. It has a low heat capacity. So what that means is that copper could like change heat very quickly. And so it could take the heat from this gas, the refrigerant, in this gas state, and push it outside the fridge very easily. Unlike, let's say you made it out of water. Water doesn't like heat. Heat change that much, so like take a while. But copper does this job very well. And so that's why on good refrigerators, it's made out of copper. Anyway, but that's basically how the refrigerator works. You have a liquid, which is a refrigerant, running through the back here, and it's taking in the heat. Let me draw this out real quick. It's taking in the heat from like your apples and crap like that. I don't know what you guys put in the fridge. Your apples and stuff, it takes that heat, puts it back there. As it runs through, it's being pushed out because there's a compressor, and then outside the refrigerator, there's the coil, and it releases the heat back in the environment. So it keeps on doing this until your food is actually, and eventually, cold, which is cool, which is a W. And it signifies the importance of insulation, because if you have a poorly insulated fridge, that heat that you just put back out could go back inside the fridge, and you don't want that. That really sucks, man, because then you're gonna have hot apples, and nobody likes hot apples. So that's why refrigerators have good insulation, and they have an efficient refrigerant like spreading system, cooling system, which is big W's. One more thing, if you guys have not clicked off, which I find pretty cool too, is that this also the concept of surface area. And you know how in chemistry class we said that if an object has more surface area, it reacts quicker to stuff. Well, that's the same with anything, really. If an object has more surface area, it is affected by the environment much more. So there's this like little spray can nozzle. I don't know the exact component name of it, but let's picture a spray can real quick. It doesn't shoot the paint in like big glops like that. It shoots it in fine mists. And so there's this component in the refrigerator that does shoot the refrigerant like a fine mist. And that's because it increases surface area. And with this increased surface area, if you have a big blob compared to a bunch of tiny blobs, it could collect heat better. And so that makes it even more efficient as the refrigerator compared to this big blob which has less surface area than these tinier, greater amount of blobs. Excuse me. But that's how a refrigerator works, guys. Comment, like, tell me if you learned something today. Stay smart, boys. Amen, brother. Peace.